In last lecture, we discuss about the three processes of light. So in these three processes, including first is absorption, second is spontaneous, and third is stimulated. So in absorption, we discuss about the how photon atoms present in ground state due to its own emission of processes. It goes to the in state. Then second process is spontaneous emission. In spontaneous emission of processes, the excited state atoms how to due to force of attraction is suddenly now goes to the ground state. So now today we are see the last process, stimulated emission. In this stimulated emission process, we first tell you about the definition of this stimulated process. When incident of photons in excited state atoms get de-excited by the incident of photons, and they will be fall to the ground state, emitting the extra energy in the form of photons. When photonic emission of processes, incident of photons, excited state atoms goes to the de-excited state, and then due to emission of that incident photon radiation phenomena, they falls in the ground state for emitting of extra energy required for these processes including. So this process happens the extra large amount of energy required. So during this spontaneous emission, an atom in the excited state need not wait. These processes, when atoms in excited state present and he goes to the de-excited state, he can't be wait for any spontaneous emission of processes. He suddenly goes to the ground state. So photon with appropriate energy defined as HV is equal to E2 minus E1. It interacts with the excited atoms. Here H is a Planck's constant, V is the frequency, and E2, E1 is the energy levels. So in this appropriate energy levels, photons with the H mu is equal to E2 minus E1, this energy state levels, it excited state atoms will be present. So next is the atom can trigger undergo to the transition to lower level and emit another photon. In this processes, the spontaneous emission of process occurred, then atoms transition state goes to the lower level, and number of emitting of photons will be radiation phenomena generated. So next is how to stimulated process will be occur. See in this way. So stimulated emission, you know, the processes in which the incoming of photon required for specific frequency with the excited state atom electron. So other excited molecular state will be emitted in that lower energy level. So when atom, see in figure, excited state level, here see incident photon present the excited state before emission of processes, atom will be present in the excited state, and E2 will be the excited state energy level. So incident of photonic radiation phenomena, the atom in excited state how will be converted into ground state atom. So during the emission of this stimulated emission of process, the H mu is a radiation phenomena with the atoms goes to the downward direction. This process will be during the processes of stimulated emission. Excited state atoms will goes to the downward direction in the ground state atom. So third diagram intended, after emission of stimulated emission of processes, the number of photons radiating energy will be here C. The atom will be goes to the C in the ground state. So in this way the spontaneous phenomena occur, but then stimulating processes including the excited state atoms with spontaneous of stimulated emission of processes, here the processing occurred, the atoms in excited state will be goes to the downward directions, means ground state atom. Since atom is already present in the excited state, in the the atoms will be present in the excited state, already he present in upper level, so and it controls the lowest possible levels of ground state. Then incoming photon, which quantum energy will be generated. The quantum energy is equal energy difference created from E2 to E1 level. So in this way, the present lower level will be stimulated due to that transition state, then producing the second photon of the same energy. First photon due to radiation phenomena converted into in the form of second photon energy will be generated. See in this figure how to second photon will be incident for radiation form will be we can see. So in this way, stimulated emission of process, the atoms already present in excited state, but in stimulating emission of processes, he goes to the force of transitions phenomena, under the influence of processes, the force due to large amount of force vibrations phenomena, the atoms in the excited state will converted into during the processing of force vibration of transition level, the atoms will be converted into ground state level, and second type of stimulation transition processing, second type of photon will be generated. Now see in third how to this process is represented. This stimulated emission of process may be represented as A dash plus HV 10 raised to A plus 2 HV. Here we know that the A dash is represent the excited state atom. So H mu is a Planck constant, A is a ground state atom, plus 2 photons will be generated in this figure. HV is a Planck's constant and V is a frequency. So the rate of stimulated emission of photons will be given by RST is equal to B12 P of V bracket close N2 is a second equation will be generated, where RST is a stimulated of emission represented. So in this way the B21 is a Einstein coefficient represent. So P of V is the inner atoms of the excited state atoms will be energy level density will be generated. So N2 is atoms in excited state, P of is a energy density level in the excited state will be defined as. So thank you.